Then we have a small numerical here. We will not do full solution of this numerical, but in this numerical we have a varying duct. So in the direction of the flow, area is increasing. When area is increasing, it means that what will happen to velocity? Velocity will decrease and pressure will increase. So this is a type of nozzle, because in nozzle, type of diffuser. In diffuser, what happens that at the expense of the velocity, pressure increases in the direction of the flow. So in this problem, the flow rate Q is constant. Q is not varying, right? When flow rate is constant, so flow as such, flow is a steady flow. Flow is a steady flow. So for a steady flow, if you talk about the local acceleration or temporal acceleration, it will be 0. But in this case, if we are assuming this as a one-dimensional flow, then there is a variation of velocity in the direction of the flow, which is x direction. If this direction is designated as x direction, so in x direction this velocity is continuously changing. If velocity is changing with the location of different point in the x direction, it means that velocity gradient in x direction exists. It means that flow is non-uniform. If flow is a non-uniform, then temporal acceleration may be 0 because of the steady flow, but convective acceleration will exist. So if convective acceleration will exist, then we need to find out del u over del x. So how do we get del u over del x? So it means that with the help of continuity equation, we have to write a equation in which u is function of x. We have to write the equation in this form. U becomes function of x. When we have equation with the help of this physical geometry and continuity equation, we can find out the equation as function of u as function of x, then differentiate this equation with respect to x del u over del x, then we will get that equation and multiply it by u. This will be the acceleration in x direction. Ax is equal to u del u over del x. U del u over del x at which point? So in this case, you are asked to find out the acceleration at inlet and outlet. So inlet x is equal to 0 and outlet x is equal to L. So in this equation of del u over del x, put the value of x as 0 and x as L, we will get acceleration at inlet and outlet, which need to be calculated in this numerical.